So applying that chain rule, we already know what the derivative of tangent of a function is. It's secant squared of that same function, so of theta. But then, since we're doing the chain rule, we also have to multiply it by the derivative of theta, which all we know right now is that that would be d theta dt. We don't have a value for that, right? And then on this side, we have 1/12 times dh dt, which we can go ahead and plug that in on the bottom. So I'll just rewrite all this. Secant dt equals, so dh dt is the rate at which the height is changing, which we already know from the problem is 2 feet per second. So this is just equal to 2. So simplified, it's just 1/6, right? And now we know that our end goal is to find this, right? The rate of change of theta, because that's what the problem's asking for. So we want to solve for that, right? And so when I move this over, that's the same thing as cosine squared theta, right? Because they're inverse. So I'm just going to do that. I'm just going to do cosine squared theta over 6. And now I have the rate of change of theta, right? So this in terms that I can define it with information I'm given in the problem. Now, what stumps people is, well, there's still this theta here, right? And we don't know what theta is. It never tells us what theta is or what any of the angles are. So how would I be able to do that? How would I, even if you knew theta, this is a non-calculator question. So how would you be able to find cosine squared theta without a calculator, unless it was, one of the classic ones that we know what it is, like 30 or 60 or whatever, right? So how would we be able to do that? Well, now we're just simplifying it to, well, what do we know, right? Well, we know that we want it at the instant when the balloon is 16 feet above the ground, right? That's important. So that means that we know what h is at the point we're trying to find, right? And d is always constant. So we know these side lengths, right? But for cosine, we would also need to know this hypotenuse length. Well, we can use basic Pythagorean theorem to figure that out. Now, you could do a squared plus b squared equals c squared, which would take a little longer, but you'd still figure it out. Or you could notice that this is 3 times 4. This is 4 times 4. So it's really just a 3, 4, 5 triangle times 4, basically. So this is going to end up being 20, because that's 5 times 4. So, if you remember your Pythagorean triples, it just cuts down that step for you. But either way, now we know at the instant that we're being asked about, which is the instant where the balloon is 16 feet above the ground, we know all the side lengths of the triangles, right? And cosine is just adjacent over hypotenuse. So we're just going to do that, right? So what this is going to end up being is the adjacent is d over the hypotenuse, which is 20, or d is 12. We know that. So 12 over 20, which is cosine of theta, right? Because it's opposite over hypotenuse. We're going to square that, and then we're going to multiply it by 1/6. So if we do that really quickly, well, first we would simplify this in our heads to, what is it, 3 over 5, right? So we'd get 9 over 25 times 6, which would be 150 over 9, or actually, we could just cancel out the 3's, whatever. The bottom line is it's 3 over 50, right? Once you simplify it all out, which is exactly what the answer looks like. Choice C, 3 over 50.